So we finished really what we did on the first couple of pages was just review of how to solve trigonometric equations, simple trigonometric equations, which we have already done. And then we departed from that for a little while, and we learned the trig identities. Because in order to solve more complicated trig functions, you need to know the trig identities. So now what we're going to do is, this first little bit is just a small review of factoring. Now, it doesn't look like the factoring you're used to because they've included the words sine and cosine, but if those bother you, you can take them out and just look at them like they're x's. So where it says sine squared theta, I can actually write that as 4x squared minus 1. And then that looks like something that I'm used to factoring. How would I factor that, 4x squared minus 1?
Set it equal to 0.
Well, that's where we're headed, yes. But before that, remember, factoring is like unfoiling. Or it's figuring out what two things you multiply in order to get this. This one happens to be a difference of two perfect squares. How do you factor a difference of two perfect squares? That would be a difference of two perfect cubes, but this would be two sets of parentheses, 1 minus 1 plus 2x in the front, take the square root of the first piece, square root of the second piece. That's it. But now I have to put back the word sine. So my answer would actually be 2 sine theta minus 1, 2 sine theta plus 1. Now eventually you'll get to the point where you don't have to take the sines and cosines out. But just for the purposes of making it look simple, or making it look like something you can recognize, I could rewrite this as x squared minus y squared. How would I factor x squared minus y squared? It's a difference of two perfect squares. Two sets of parentheses, 1 minus 1 plus. Square root of the first piece in the front, square root of the last piece in the back. Now I put back the words. Sine theta minus cosine theta. And sine theta plus cosine theta. Okay, so real quick review, because every time y'all seem to be staring at me dumbfounded. X squared minus 9. How does that factor? X plus 3x minus 3. 64 minus y squared. How would that factor? 8 plus y, 8 minus y. Let's see. 4x squared minus 81. How would that factor? Minus 9, 2x plus 9. Okay, here's one. Don't forget this one because this is the one that everybody forgets. X squared minus 1. X plus 1, x minus 1. See, 1 is a perfect square, so don't forget that. Okay, because the same thing will happen on these. Alright. So now, on the next one, even before I get to, well, let me write this as, even before I rewrite it with x's and y's, because I think you can clear up, see, there's a GCF here. There's two terms, they're separated by minus. What do these two terms have in common? Cosine. So I'm going to factor that cosine out. And if I do that, I'm left with sine squared theta minus 4 cosine squared theta. Now, if the words sine and cosine trip you up and you're confused, I could change all my cosines to y's and all my sines to x's, and I would have y replacing the cosine on the outside, x squared minus 4y squared. How's that piece going to factor? X plus 2y, x minus 2y. Now just go back and put back your words. So it's going to be cosine theta, and in parentheses, sine theta plus 2 cosine theta, and sine theta minus 2 cosine theta. Alright, now down on this next one, I have 3 terms. See, I've got a minus and a minus. So there's a sine squared, that's one term. Sine and 15, 3 terms. So this is a trinomial. So I am going to take the sign out and just look at what it would look like without it. X squared minus 2x minus 15. How would that one factor? So you're looking for the things that you would multiply to get 15 that you add to get 2.
3 and 5.
5 and 3. Which one's negative? Which one's positive?
Negative 5.
Minus 5 plus 3. Put the word back. Sine theta minus 5. Sine theta plus 3. Alright, so now I have 4x squared plus x minus 3. Again, it's a trinomial, not as straightforward as the last one. How am I going to solve this one? You got to multiply the 4 and the 3, bottoms up method. So I'm going to multiply 4, negative 3. So that's going to give me x squared plus x minus 12. Now I can factor that trinomial as x plus 4, x minus 3. And then don't forget, this was bottoms up method, so that 4 has to come back as a denominator. So I'm going to divide by 4. So this 4 is coming back. So the first one simplifies to x plus 1. The second one becomes 4x minus 3. Now you can put back the tangent. So this would be tangent of theta plus 1. And this one's 4 tan theta minus 3. I'm going to write this as x to the 4th plus 2x squared plus 1. Do not let it bother you that this is x to the 4th, because this is x squared. So factoring this is the exact same thing as factoring something that's squared in the front and linear in the middle. Okay, so it's just the same. So this is going to factor as x squared plus 1 and x squared plus 1. Because 1 times 1 is 1 and 1 plus 1 is 2. So it factors the same way. And then I'm just going to put back the cosine. So this will be cosine squared theta plus 1. And this is cosine squared theta plus 1. Okay, so that's just a little practicing of factoring. Now, we're going to have to use everything that we've learned to solve these equations. We might factor, we might use some trigonometric identities, we might just be able to straight up solve them. We'll see. Okay, so in this case, I have 2 sine squared theta, sine theta plus 1. So just in order to look at it a little bit less crowded, I'm going to write it as 2x squared equals x plus 1. Now it looks like just solving a regular old quadratic. If I were solving a quadratic like this and I have x squared and x in the same problem, what do I need to do? Move it all over, set it equal to 0. So I'm going to keep it positive, move it all to the left. So 2x squared minus x minus 1 is 0. I have a lead coefficient of 2, so I am going to have to bottoms up this. Multiply first and last. 2. So I get x squared minus x minus 2. We will factor that as x minus 2x plus 1. Don't forget, this is the step everybody forgets on this. Don't forget, bottoms up method, that 2 that I just dropped off has to come back as a denominator. So the first binomial simplifies to x minus 1 and 2x plus 1. Now, let's go back and put sine in it. So I have sine theta minus 1 is my first binomial, and 2 sine theta plus 1. Now, thinking back, just even one step, but just to solving quadratics. If this was just a quadratic, when we got to this step, we could find our 2 answers. Remember, quadratics are squared, so they should have 2 answers. We would find our 2 answers right here. I would say x equals 1 and x equals negative 1 technically what you're doing is setting each piece equal to 0, right? So let's do another one real fast just for the sake of having it. So let's say I have x squared minus x minus 6. That would factor as x minus 3, x plus 2. So x minus 3 equals 0 and x plus 2 equals 0. So x equals 3 and x equals negative 2. Y'all remember doing that, solving quadratics? Okay, nothing is different here. Once you get down to this place right here, you have two separate equations. You are going to take your two equations and set them equal to 0. So sine theta minus 1 equals 0, and 2 sine theta plus 1 equals 0. And now we're just solving for theta. So we're going to add 1 to both sides. And I get sine theta equals 1. Now I'm just going to do this left-hand equation first, and then we'll do the right. Now, my goal here is to solve for theta. Get theta alone. What is with theta that I must get rid of? How to get rid of sine? Arc sine. So if I arc sine the left to get rid of sine, I have to arc sine the right. Now, 1 is a unit circle value. So where on the unit circle does sine equal 1? Straight up, right? Which is what in terms of radians? What's pi over 2? Is there anywhere else on the unit circle where sine is 1? Down it would be negative 1, right? And in this case, they only wanted positive 1. So that's, in this case, this value only has one answer. Is everybody okay? So now let's do this one. Subtract 1 from both sides. So now I have 2 sine theta equals negative 1. Divide both sides by 2. That sine theta equals negative 1/2. I've got to get theta alone, so I need to arc sine. Alright, so now I am looking for where sine equals negative 1/2. Now, I can figure out where sine equals half using the left-hand trick. Top fingers or bottom fingers? Bottom. I need one finger on bottom for 1/2, so I fold in this finger. What angle is that? Pi over 6. Now, in quadrant 1, it's positive. Where is sine negative? 3 and 4. So I need the ones that have 6's on bottom in quadrant 3 and 4. So this is 6 pi over 6, right? Straight out is 6 pi over 6. So what would be in quadrant 3? 7 pi over 6. So I know it's going to be 7 pi over 6. And this is 12 pi over 6. So what would this be? 11 pi over 6. So this one has 3 answers. Okay, so now the tricky part about these is just knowing what to do first. And it just takes practice, being able to look at it and figure out what comes when and don't comes. Hello? Just making sure it's not my interest. Okay. In this case, the goal here is to get theta by itself. And currently I have 2 separate thetas, one on each side. So probably the first thing you need to do is move all your thetas to get together on one side. So I'm going to move this over. So I have sine 2 theta minus sine theta. Okay. Now the next thing is this is a double angle where this is a single angle. So I need this double angle to not be a double angle anymore. Anybody remember what identity I can change that with? Good. 2 sine theta, cosine theta. That replaces all of that. Minus sine theta. Alright, now I have sines and cosines in the same problem, but it's really okay because there's a GCF. The 2 terms, they have sine in common. So let's go ahead and factor sine out. So it's going to leave me 2 cosine theta minus 1. now I have two factors. I can set them both equal to 0. So sine theta equals 0, and 2 cosine theta minus 1 equals 0. The whole goal in all of these is to get theta by itself. So in the left-hand equation, I'm going to arc sine. Where is sine equal to 0? At pi, yes. Is that the only place? 2 pi. It would be at 0 also, but if you look at your interval, the 0 is not included. It's 0 at 0, at pi, and then again at 2 pi. But the only ones that apply this time are pi and 2 pi. Now on the right-hand piece, we've got to get theta by itself, so first I'm going to add 1. And divide by 2. So I got cosine theta equals 1/2. We need to arc cosine here. Alright, left-hand trick, top fingers or bottom fingers? So I'm going to fold in this finger, which is pi over 3, and that is positive, quadrant 1, so pi over 3 is an answer. Where else is cosine positive? Quadrant 4. So what has a 3 on bottom in quadrant 4? This is 6 pi over 3. So what would we find? Yeah, that's it. Alright, how are we doing so far? Okay? Alright, I'm going to change these to x's just to look at it. Now if this were quadratic that I was trying to solve, I would move everything to the left. So I'm going to go ahead and